Okay, here we go, the very last question on this paper. Question 8, we'll start with A as always. It's a circle question, so quite easy, this is quite simple. There is one trick, I'll come up with the trick in a minute, but for now you get given a point here, C, which is the centre of the circle, and you get told put the circle in this form. That's a standard form for a circle. Well, you just sub in what you get given. So that 3 is your x point, that minus 8 is your y point. So when you go to sub in, you go x minus 3 all squared. That 3 is that a there, plus brackets y minus minus 8, so plus 8 there, squared, never forget the squared, and the trick here, which you may already know about, you may not, radius 10, 10 is not k there. It's very easy to think, oh, I'll just put 10 in there. It isn't that, it's 10 squared. So quite easy to get caught out like that, but just means that your answer is going to be x minus 3 squared plus y plus 8 squared equals 100. There you go, that's your answer for the first one. Not too difficult if you remember that trick, which I hope you will after I've pointed it out 8 times. Anyway, question B. Find the x-coordinates of the point where the circle crosses the x-axis. So, as you know, the x-axis is just a line. It's a line across, going from left to right, and if you think about it, that line is y equals 0, because everywhere along the x-axis, y never changes, it is always 0. So, if y is 0, then you can put y is 0 into the equation that we just got, the formula we just got, and find some x-coordinates from that. So, let's do it. Let's do x minus 3 squared plus 0 plus 8 squared equals 100. Right, let's times out those brackets at the beginning. So we've got x squared minus 6x plus 9. There we go, plus 9 plus 64 equals 100. Now it looks like we're going to get a quadratic out of this, so let's put it into something we recognize a little bit more with a 0 on the end of it. Let's take away 100 from both sides and put this 9 and 64 together. And I think what we get, yes, we get x squared minus 6x, then that minus 27 equals 0. Standard quadratic. So what we're going to do here is have two sets of brackets. We've got x plus 9, and x minus 3 equals 0. So x is equal to minus 9 and 3. Okay, they are your two x-coordinates. Hang on, I've done that wrong. I've done that a little bit wrong. This is a hang on. This is a minus 9 there, and this is a plus 3 in there, which obviously changes this to a plus 9 and a minus 3. Right, I nearly got caught out there, and I've been doing this an awful lot longer than you have. So, x minus 9 and x plus 3 is equal to 0, so x is going to be equal to plus 9 and minus 3. So they are the x-coordinates of the points. If you put that back in to the original equation, you will get y equals 0, or you should do, which is how you can check that that's right, if you don't trust the mark schemes for some reason. But in the exam, if you want to check whether you're right, that's how you can do it. So, next question, C. Now, it really helps with this question, if you have time, if you have the patience, if you want to, you can draw out a sketch for this. So draw out a rough sketch. This isn't going to be kind of correct if you just do this. Just draw a random circle somewhere that crosses the x-axis in 2 points. So these will be the 2 points that we just figured out a minute ago. Okay, we've got C in the middle. Let's draw C there, big green C in the middle there. Now it tells us that we've got a tangent to the circle. There we go, a tangent to the circle. So just some line that comes across here. That's supposed to be a straight line there. That doesn't cut the circle, doesn't miss it. It just kisses the edge, just touches the edge of the circle there. And it says it's a tangent to the circle at the point A. So let's call that point there A. Right? It has a gradient of 5 over 2. That's its gradient. Now what it wants us to do is find out what the equation of the line is that goes through A and C. So this line here is what we want to find out. So hopefully you know how to do that. The gradient for that line is going to be this 5 over 2, but flipped over and given a minus. So if we flip it over, instead of 5 over 2, we get 2 over 5, and put a minus in front of it. That's the gradient of our new line. Probably shouldn't have used blue twice, but never mind. Minus 2 over 5, that's going to be the gradient of our line. And then we have the point 3 minus 8, because we know it goes through C. So we get the point, here we are, 3 minus 8. So let's put that in with the formula that we all know, we've all used 100 times, which is y minus y1, y minus 8, so y plus 8 equals minus 0.4 or minus 2 over 5 if you like. I like decimals, so I'll use that. X minus x1, which is x minus 3. Right then, let's times out the brackets and move some things across. So let's go for my blue again. Y plus 8 equals minus 0.4x plus 1.2. Now if you're using fractions, you obviously have a slightly varied version of this, but 1.2 it is for now. And the next thing we can do is try and get it, because we're trying to aim for this form here with a 0 on one side. So let's start moving some things across, and what we're going to get is y plus 0.4x, then plus 6.8 equals 0. Now obviously we need, there we go, it says it there, it says integers there, so let's times that out by 5. If we times everything there by 5, then we are going to get integers. We're going to get 5y plus 2x plus 34 is equal to 0. That's our answer for that. That's probably as difficult as this question number 8 is going to get. Really, if you're using fractions, then you might have found that last multiplication a little bit easier, but if you weren't, then good for you for doing it the hard way. Right, DI, where are we? DI, there we go. Show that the x-coordinates of the point of intersection satisfy the equation. Oh, here we go. Right, you've got y equals 2x plus 1. So what we need to do for this question is put y equals 2x plus 1 into our original equation from A. So instead of writing y in there, we're going to write 2x plus 1, and what they're telling us is it's going to end up looking like this. So let's do that. It's going to be quite messy, but never mind, do it anyway. Right, so give myself a bit more space here. x minus 3 all squared plus big brackets, little brackets, 2x plus 1. We've just replaced the y with 2x plus 1. Then plus 8, close that, all squared, is equal to 100. Right, let's see if we can simplify that a bit. We've times out this initial part in an earlier question, so let's get x squared minus 6x plus 9. That's what that bit is. Then plus, here we go, plus, what I'm going to do here is get rid of this little bracket. Get rid of the little bracket, so you get 2x plus 9. 2x plus 9 all squared equals 100. I know it's a little bit messy now. Hopefully you're following me and you understand what's going on, but I mean, you can work through it yourself and get yourself to a situation where you have something roughly similar to this down here, but I'm going to persevere like this. I'm going to times out this bracket here. We've got a squared up there. I want to get rid of that. Okay, so that up there, when we times that out, is going to be 4x squared, this is very messy, plus 18x plus 36x plus 81. That's what that bit in the brackets there is going to be. If we put that in with the rest of it, holy moly here, right, we're going to get 5x squared minus 6, so plus 30x, then plus 9, plus 81. I'm going to take away the 100 as well from both sides. Take away the 100 from both sides, and we end up with minus 10 equals 0. Okay, being quite methodical with this. I don't want to make any small mistakes whatsoever. We can divide all of this, all of that there, divide everything by 5, and lo and behold, we do get x squared plus 6x minus 2 equals 0. Just like they said. So, moving on to the last one now, very last question of the exam paper. Right. Here we go. So hence show that the x-coordinates of the point of intersection are of the form m plus or minus root n. Right, the only way we can do that is to use the quadratic formula on this one that they've just given us. The reason why they gave us that, really, is so that you can do this question without having to have answered. If you haven't been able to answer DI, don't worry, because you can normally, when they give you the answer, when they say you're working towards this, normally means you need that for the next question, so don't worry, you can do the next question more times than not. But anyway, I don't know why I'm being so negative. You probably could do that question. So, the quadratic formula, as we know, is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I think you have to remember that. I don't think they give it to you. I think they gave it to you at GCSE, but I don't think they give it to you now. So, hopefully you remember that. And let's just put in the numbers that we've got. So, that is equal to minus 6 plus or minus the square root of 36, b squared, 36, 6 squared, minus 4 times a, which is just 1, so 4 times minus 2, so minus 8, so plus 8, I think, and divide that all by 2 times 1, which is 2. Now, a little bit tricky here. Okay, you have to know your way around surds for this part. Let's write that out a little bit more neatly. We get minus 6 plus or minus square root of 44. over 2. Now the minus 6 and the 2, you can just divide that minus 6 by 2. So that's not a problem. You get minus 3, obviously. You can't do the same with the surd. You can't say root of 44 divided by 2 is the root of 22. It doesn't quite work like that. What you've got to do is say, if you've got the root of something divided by 2, take what's inside the root, divide it by 2 squared. Okay, so it's almost like, I don't know what it's like, but you've got to say that when you have a root of something, root 44 divided by 2, take the number inside the root and divide it by whatever this number is, happens to be a 2, square it, and then you'll get root 44. So 44 divided by 4 is 11, so minus 3 plus or minus root 11. That's your answer there. Well done, you have finished the exam. Hope you did well. See you on the next one.